Hey everyone, have you ever wondered how radars, satellites, and even microwave ovens amplify signals at super high frequencies? Well, it all comes down to something called velocity modulation. Today, let's break it down in a super simple way. It is used in devices like klystrons, PWTs, and magnetrons. Here is the figure of klystron. It helps in amplifying microwave signals and it's crucial for radar, TV broadcasting, and satellite communication. Here is a radar, and this is a satellite. Now, the question comes, what is velocity modulation? Let's take an example. Just imagine you are driving a car on a highway. At first, everyone is driving at the same speed, like an unmodulated electron beam. This is an unmodulated electron beam. But then a traffic signal turns green, yellow, or red ahead, and some cars speed up, some slow down. This creates groups or bunches of cars, just like electron bunching in velocity modulation. In this figure, we can see the group of electrons or electron bunches. These branches later transfer their energy, amplifying signals. So basically, velocity modulation is a process where we control the speed of electrons, making them bunch together and then use that bunching effect to amplify signals. This is a figure of two-cavity klystron, which follows the process of velocity modulation. In this klystron, we can see there are two cavities. The one is buncher cavity taking RF or radio frequency signals as input, and the other one is catcher cavity releasing a stronger RF signal as output. There is a drift space between these two cavities. Then there is also a cathode and anode which forms an electron gun connecting with a battery. And there is a collector which absorbs the spent electron from the catcher cavity. There are five grids in this klystron. The first grid at the electron gun, which controls electron emission and beam focus, and the grids 2 and 3 at buncher cavity basically assist in velocity modulation to enhance RF field interaction with electrons. And the grids 4 and 5 at catcher cavity maximizes energy transfer. Now we'll know about how velocity modulation works. The first step is electron gun. An electron gun generates a steady stream of electrons moving at the same speed. Now the second step is buncher cavity. We apply an RF signal inside a cavity. This causes some electrons to accelerate while others slow down. Then the third step is drift space. As electrons travel through the drift space, the faster ones catch up to the slower ones, forming electron bunches, as we showed before. At the step 4, the catcher cavity, finally these bunches hit a catcher cavity, releasing their energy as a stronger RF signal. And the collector collects the spent electrons from the catcher cavity. Now we will see the real-world applications of velocity modulation. Klystrons used in radar TV transmitters, traveling wave tubes used in satellite for communication, and magnetrons powers microwave ovens. So next time you heat up your pizza in the microwave oven or use a satellite-based communication Just remember, velocity modulation is working behind the scenes. Now, here are some pros and cons of velocity modulation. The pros: it works at very high frequencies, efficient and reliable, it can handle high power. And the cons are: it is bulky and expensive, it requires precise tuning. And that's velocity modulation in a nutshell. Pretty cool, right? Now you know how signals are amplified in radars, satellites, and even microwave ovens. Thank you.